Okay, right. Welcome to discussion 9. Today we are mostly gonna go over some review problems, but before that, we just want to talk about something. So let's do that first. So just a reminder about the course expectations that you are expected to, and these are all mentioned in the syllabus, okay? Just a reminder again. You're expected to participate in the course through the lectures, discussion section participation, and other engagement. All the lectures are recorded and they're usually posted within 4 hours after the lecture ends. So if you miss a lecture, you should watch the recording as soon as you can. Also, please make sure you use the opportunities to get help outside the class. You can use office hours, you can email us, you can email the TAs and the instructor, okay, if you need any help. All right. So just a quick reminder that math is not, math is learned by doing. So you have to do stuff. You have to spend your time to solve problems. And to be successful, you should plan to review your lectures, right? You have to do it. You have to understand the solutions. And then you review your homeworks, your quizzes, your lectures, your worksheets, and understand the methods rather than just specific examples, okay? So even though, today's worksheet's not about R, sorry, I'm just reading a question in the chat. Is there any way you can start to open the worksheets? Before coming to discussion, not having any idea what to expect. Okay, so this is the policy that the worksheets open up during the lecture, at the start of the lecture. What the point of the worksheet is to, as if we were in the physical school, right? We would come and we would do the worksheets in the class together with the peers. Now, since it's COVID, everything's online, they'll still open up at the time your class starts, but we just give you some extra time. But they're supposed to be done within the discussion section. They're supposed to be finished by the end of the discussion section, okay? After we review the slides of that day. Okay, so just a quick thing about R, right? Even though today's worksheet's not about R, but just a little bit, that even us today using R, we get frustrated sometimes when our code doesn't work or it doesn't go the way we want it to go, right? Please, it's okay. Don't blame yourself, okay? It's not your fault. Sometimes it's just the machine, right? So just, calm down, take a break, talk to your peers, talk to the instructor, talk to the TA, but don't blame it on yourself that it's your fault that the code is not working. Code is not magically just started working, okay? Maybe you're making a typo. Maybe, it's just a machine that's stuck. So just keep it down, keep it calm about that and talk to someone. And then you can also, if you have question about some syntax of a function or just a function itself, how is it working, you can always go to the help menu in R, or you can also say question mark and then the function you want to find out more about in the R Studio, and it will give you a description about what the function needs and what is the function doing, okay? Okay, so today we will go over these few questions from your quizzes. And then please let me know if you have any questions. Please, you can stop me in the middle. It's okay to stop me in the middle and ask questions if you have any. I would love that. Okay, so the first one's from video quiz 6, question 9. The question has two random variables, x1 and x2, and both are independent, and they both follow a uniform distribution from 0 to 1. Okay, so x1 belongs to uniform distribution from 0 to 1, and same for x2. Now we are introducing a new variable called z, which is the maximum of those two variables, x1 and x2. We want to find the PDF for z, okay? So just a hint that this question was similar to the example you guys went through in lecture 19, okay? But also, from lecture 18, we know that if we have n independent random variables with the same density and distribution functions, so they should belong to the same distribution, then when we define m as the maximum of those variables, the CDF, the cumulative function of m, is just the cumulative function of x raised to the power of n. And what is n here? Anyone? What is the little n here? Any guesses? No? I think I have something in the chat. Yeah. No one else? The little n is the number of those variables, number of those x independent variables. So if you see, there is x1, x2, and it's still xn, right? So if these xn are independent random variables, then with the same density and distribution functions, the PDF and the CDF, then when m is the maximum of those n independent random variables, then the CDF of m is just the CDF of x to the power n, okay? And since we only, so how many variables do we have in our question? We say suppose x1 and x2 are independent random variables. So how many variables do we have? Anyone? 2, good. Thanks, Ariana. Cool. So we have 2 variables in our question. So our n is 2. Okay? So let's go further and see how to do this. So in this case, n is 2, and both of those two variables, both of those two random variables are independent and they follow the same distribution. So they have the same PDF and same CDF. Now, what is their PDF and CDF? We know from lecture 14 and chapter 5 that the PDF of a uniform distribution looks like 1 when x is between 0 and 1, and it's 0 otherwise. And then the CDF is 0 when x is less than 0. It is x between 0 and 1, and it is 1 when x is greater than 1. So now that we have the CDF of x, can we find the CDF of z, which is just the maximum of those two variables? Yes, we can. So how do we do that? Again, using the above reasoning, when m is the maximum of the variable, so here we have z, which is maximum of x1 and x2, it should just be the CDF of z should just be the CDF of x squared, because n is 2 here, okay? So that's what we did. We found the CDF of z, which is the square of the x. So we have 0, well, z less than 0, 0 squared is just 0. And then z squared, because we squared the second one when z is between 0 and 1. And again, 1 squared is just 1, so 1 when z is greater than 1. But our question was to find the probability density function. We just found the CDF. So to find the PDF, we just find the derivative with respect to z to get the PDF of the function. Is that clear? Any questions? I've got a couple yeses in the chat. Okay, good, thanks. Any questions so far? Okay, all right, let's move on to the next one. So the next one is from the homework quiz 7 and the question number 3. So the question says, let x be a random variable with mean mu and standard deviation sigma. What is the expected value of x squared? Okay. What is the other name for expected value? What are we trying to find? Other name for expected value. Can we call it mean? Good, good. Yes, yes. Thank you. Yeah. Thanks, people in the chat. Yes, it is mean. Okay. So here, you might think, because we have a random variable x, and we know the expected value of x is given as mu, and the standard deviation is given as sigma. So we would be like, okay, maybe we change the variables, but it's not that hard here. It's fairly very simple example. So we know the formula for variance of x, right? So variance of x is expected value of x squared minus the whole square of expected value of x. Now we have the variance of x, right? We have the standard deviation, and if we just square the standard deviation, we get the variance of x. So we have variance of x as sigma squared, and we also have the expected value of x, which is just the mean of x, which is mu. So if we solve for expected value of x squared by rearranging the variables, it should just be variance of x plus the square of expected value of x, which is just sigma squared plus mu squared. And that's it. That was the whole thing. Any questions? Is it clear? Is it not clear? Good. Okay, I've got a few thumbs ups. Okay, cool. Thank you, guys. Okay, so let's look at the next one, which is also from homework quiz 7, but this is question 6 now. We are given x to be a continuous random variable with the PDF as 1 over pi times 1 plus x squared. And then we define a new random variable y, which is just 1 over x. We need to find the mean of y, okay? Or in other words, expected value of y, okay? So let's see. So also just a hint that if you worked on question 5 in homework 7 before taking the quiz, this should be fairly similar to that. Okay, so based on the hint given in the homework 7, this question is almost identical to the example in the textbook, okay? So PDF of, by that hint, we know that the PDF of y, which is y is 1 over x, the PDF of y is exactly the same as PDF of x, okay? So at least that we know that the y has the same distribution as x, okay? That's good to know. So what is the PDF of x? The PDF of x is a Cauchy distribution, okay? Looking at the formula for the PDF, it is a Cauchy distribution, okay? So that means we know that the PDF of y is also Cauchy distribution. And in lecture 13, we show that the expected value or mean of a Cauchy distribution is undefined. So that means the mean of y is undefined. Is it okay? Are you guys okay with this question? Yeah? Okay, I've got a few thumbs up. Any questions, anyone? Should I move on to the last one? You can tell me in the chat if you want. Yeah? Okay, I've got one in the chat. Okay, the last one is from homework quiz 8, question 7. We have a joint PDF for x and y, and it's given as 12 over 5 xy times 1 plus y if x is between 0 and 1 and if y is also between 0 and 1, and it is 0 otherwise. Now the question is, are x and y independent? Now, what do we need to show if two of the variables are independent or not? Remember, we have a joint probability. So anyone has any ideas? Anyone? All right, let's see what the chat says. So my question is that if anyone knows, how can we show if two random variables are independent? What do you mean by dependent? I just want to see, how can we show that x and y are independent? see if one result affects the others. So, okay, there is a trick to show that. The mathematical, yes, it does. Thank you. That's absolutely it. So the way to show it is if the marginal of x, the marginal PDF of x, times the marginal PDF of y, if we multiply both of those, and that results in this joint that's given to us, the joint PDF for x and y, then x and y are independent, otherwise they're not. Okay? So let's see how we do that. So let's first find the marginals. Okay, so here it just says that how to show. We find the marginal of x and marginal of y, and then we multiply them to see if they are independent or not. Okay, so this is a joint. To find the marginal of x, we integrate our joint PDF with respect to y, and then our bounds for that are 0 and 1. So we integrate within those bounds, and we get 2x. And it is 2x when the bounds are 0 and 1, and it is 0 otherwise. Okay? Now, the marginal for y is exactly the same, except now we are integrating with respect to x. And then if we do that, we get, and again, if we look at the bounds for x that's given to us, they're again 0 to 1. So between 0 and 1, if we integrate, we get 6/5y times 1 plus y. And again, if the marginal of y is 0 otherwise. So if we multiply the marginal of x, which is 2x, and marginal of y, which is 6/5y times 1 plus y, we see that we get to the joint PDF that was given to us. That means x and y are independent. Is that clear? Any questions? No, I've got thumbs ups. Yes, absolutely. I can go over the last part. So we found the marginal of x, which came out to be 2x when we integrated. Then we found marginal of y, and we got 6/5y times 1 plus y after the integration. So now to check if the x and y are independent, we multiply these two marginals. We multiply the marginal of x with the marginal of y. So if we multiply 2x with 6/5y times 1 plus y, we get 12/5xy times 1 plus y, which is exactly what we had for the joint distribution. The joint PDF, I mean. Yeah? Does that make sense, Taisha? Okay. Cool. All right. Any other questions? No questions? All right, then I